In this video, we shall be talking about projectile motion. And under projectile motion, you first of all start with the definition that projectile motion is the motion of an object which has been thrown or projected into the air and allowed to fall under the force of gravity. So under projectile motion, we have three cases of looking at projectile motion. One of them is an object that has been thrown vertically into the air. So for that object, see how its motion will go? You threw it vertically upwards, so it went up and it fell down following the same pathway. For that one, we just treat it as motion under gravity. So, and we also have when we are at a platform, let me just use this as a platform of any kind, and we have an object. So we throw an object from this platform. We call it horizontal projections. So we threw it horizontally this way. So the object falls this way to meet the ground. So this is another case of projectile motion. So for this kind of motion, we now see that this object, let's say it's a ball like this. For this object that it underwent a vertical motion, which is the falling down from here to here, so vertical motion, and also a horizontal motion. So did you see from the foot of this platform to this place where it landed at? And then we also have another case of projectile motion in which that object is from the ground, it's thrown upward at an angle, thrown upwards this way, so it goes in a full parabola like this. So for that object too, so it's thrown up through this way, you threw something up, and then we also see that there is vertical motion, and then this is the maximum height, capital H, maximum height, and then there is also a horizontal motion, which we call the range. So in this video, you can see horizontal projections. So we will be treating this kind of motion for horizontal projection. So once you hear that an object was thrown horizontally, projected horizontally, or whichever way it's called, whichever word is used, you will see something that will tell you is a horizontal projection. So we'll handle it this way. And then in a later video, we are going to look at this one thrown at an angle theta to the horizontal that goes in this full parabola. Okay, now here we have this question. Now let's look at it. A stone is projected horizontally from the top of a tower with a speed of 5 meters per second. It lands on the ground level at a horizontal distance of 20 meters from the foot of the tower. Calculate the height of the tower. So we are going to draw its motion. We can see it's a horizontal projection, projected horizontally. So I always like to draw the horizontal motion, the horizontal projection motion. So this is the tower. It's projected horizontally with a speed or velocity. So U is equal to 5 meters per second. And then it lands on the ground level at a horizontal distance. So that is our range, 20 meters. We call the horizontal distance the range. And then we've been asked to find H, that is the height of the tower, the vertical height of the tower. Now for projectile motion like this, we have this formula, this equation of motion. We have that distance, let's call it S, is equal to ut plus half gt squared. So this is the formula we'll be using to solve horizontal projections. And then this vertical motion is just totally dependent on acceleration due to gravity. It is independent on the velocity of throw, the velocity or speed with which you threw that object. It's not dependent on this vertical height. It just falls under gravity. But the horizontal length, the range, is totally dependent on the velocity or the speed of throw. So if you have a higher speed, you throw it at a bigger speed, it will go further If you throw it at a lesser speed, it will just go, maybe land around here. So because of that, we can see that this equation is divided into two. This place is dependent, this part of the equation is dependent on u, the initial velocity, the velocity of throw. So this part solves for us the range. So the range is equal to ut. And then this part, acceleration due to gravity g, solves for us the h. So let's use this example to see. So we have this. That means we are looking for h, and we have this. And of course, we are given that acceleration due to gravity, the constant, as 10 meters per second squared. So let's go into it. So now we have range, we have u. So we have this part of the equation. We have that r is equal to ut. So we substitute. R is 20. U is 5, and then we get the time. So that when we find the time, we now place it here to now be able to find the height of that tower. We divide both sides by 5, right? And by the time we divide both sides by 5, we have that time. The time it takes that object to fall is 4 seconds. So this is it for this part. But that's not all we were asked to do. We are asked to find the height of the tower. So we have that h is equal to half gt squared. So h, the height, is equal to half times g, which is 10, and the time is 4 squared. So this is equal to half of 10 is 5, and then 4 squared is 16. 5 times 16 is 80. So 80 meters is the height of the tower. You can see it's just easy, and the formulas are easy to remember. So let's go into more examples to be able to understand better. A ball is projected from a height of 20 meters above the ground with an initial velocity of 0.4 meters per second. Calculate the horizontal distance moved by the ball before hitting the ground. So we can see it was projected from a height above the ground, and we didn't see any angle of projection, so it's a horizontal projection motion. So like I like to do, I'll draw the pathway for the horizontal projection. So here we have 20 meters above the ground. So that is the vertical height, the height above the ground. So we have that h is equal to 20 meters. And then initial velocity. So u is equal to 0.4 meters per second. Calculate the horizontal distance moved by the ball before hitting the ground. So we are looking for the range, the horizontal distance moved by that ball. Okay, and of course we are given our constant g. So for here we are given the height, and we are to find the range. So we start from the part that deals with the height. The vertical height is equal to half gt squared. So we substitute so we can find time, and then we now substitute into range to look for it. So most times you just find time with any of this. Like if you're given this, you use it to find time. If you're given this, you use it to find time. So we have half times 10 times t squared is equal to the height, which is 20. Half of 10 is 5. So 5t squared is equal to 20. And then we divide both sides by 5. And we have that t squared is equal to 4. We take the square root of both sides, and we now have that t time is equal to 2 seconds. So we have found the time. We now substitute it into the part that deals with the range. The horizontal distance range is equal to ut. So it's equal to u is 0.4 meters times t, which is 2. And we have that it is 0.8 meters. That is our range. Now on to the next one. A body is projected horizontally from the top of a cliff 45 meters above the ground. So let me draw so I can easily place the parameters where they should be at. So we have u, and then from the top of a cliff 45 meters above the ground, that is our vertical height, 45 meters. And then if the ball lands at a distance 30 meters from the foot of the cliff, so that is our range. You should always pay attention to find out which one is the height and which one is the range. Calculate the speed of the projection. So for this case, this is what we are looking for, the speed of throw. And since it's range that deals with that, so we have to start with this, find time from the height part of the equation, and then we now go back to this to find u. Okay, so we have that h is equal to half gt squared. G is the constant given to us, so we have that 45 is equal to half times 10 times t squared. We have that 45 is equal to 5t squared. We divide both sides by 5. We have that t squared is equal to 9. We take the square root of both sides. We have that t is equal to 3 seconds. So now that we have found the time with which the ball fell from the cliff to the ground, we now say that range is equal to ut. So range is 30 meters and it's equal to u, we don't know that, times t, which is 3. We divide both sides by 3. We have that the velocity of throw, the initial velocity, is equal to 10 meters per second. You can see it's very easy, right? So let's do one more. A ball is projected horizontally from the top of a hill with a velocity of 20 meters per second. So let's draw a horizontal projection motion diagram so that we can place our parameters rightly. You know you mustn't draw this. You can just write out your parameters. Okay, so with an initial velocity of this, if it reaches the ground 4 seconds later, so here we are given that the time is 4 seconds. What is the height of the hill? So we are looking for h. Here we've not been asked for the range, and we are given this. So we have that the height is equal to half gt squared, and we have our g, we have our t. So the height of the hill, h, is equal to half times 10 times t squared, which is 4 squared, which is equal to 5 times, that's half of 10 is 5, 4 squared is 16, 5 times 16 is equal to 80, so 80 meters. So you see here, we didn't even make use of the initial velocity because what we were asked to find is the maximum height. That is the height of the hill. So you mustn't use every parameter that is given to you. Just stick to the formula and the right formula. So handling horizontal projections, you can see it's very, very easy.